So this chapter is useful to describe the physical properties of matter quantitatively by using numerical values with suitable units. So in this chapter, we are going to study about matter. So you know what is matter? So matter is made up of, so matter is nothing but anything which occupies space and has mass. It is called as matter. So matter exists in three states. What are the three states? Solid state, liquid state, and gaseous state. So we already know that in solid, the particles are very close to each other. So the particles are very close to each other and there is no much freedom for the movement of the particles. So solids have definite volume and they have definite shape. So the next classification is liquids. What are liquids? So this chapter is useful to describe the physical properties of matter quantitatively by using numerical values with suitable units. So in the chapter, we are going to study about matter. So you know what is matter? So matter is made up of, so matter is nothing but anything which occupies space and has mass. It is called as matter. So matter exists in three states. What are the three states? Solid state, liquid state, and gaseous state. So we already know that in solid, the particles are very close to each other. So the particles are very close to each other and there is no much freedom for the movement of the particles. So solids have definite volume and they have definite shape. So the next classification is liquids. What are liquids? So liquids, in the case of liquids, the particles are close to each other, but they can move. So when compared to solid, in liquids, the distance between the particles is larger than in the case of solids. So the particles can move somewhat. The freedom, there is some freedom of movement. So liquids have definite volume, but they do not have definite shape. So gas, the third classification is gas. So in the case of gas, the particles are far away from each other. So their movement is easy and they can move fast. So they have neither definite volume nor definite shape. So the three states of matter can be interconverted from one state to another state by changing the either temperature or pressure or both. So you know that from solid, so solid can be converted into a liquid. So by heating. So when you heat, the solid is converted into a liquid. So liquid on further heating, it is converted into vapor or gas. So the reverse, so when vapor or gas, when it is cooled, it is condensed into a liquid. So the liquid on cooling, it is converted into a solid. So these are the three states of matter. So now we are going to study about the classification of matter. So matter, it is classified into mixtures and pure substance. So the pure substance, again, it is classified into elements and compound. So pure substance, it is classified into elements and compound. And mixture, it is classified into two types, homogeneous mixture and heterogeneous mixture. So mixture, it is classified into two types. So first type is homogeneous and second type is heterogeneous mixture. So matter. So we know that matter is anything that has mass and occupies some space. So first we are going to study about mixture. So what is a mixture? So mixture have two or more pure substances, so which are present in any ratio. So that is, the ratio is varying. So they have variable composition. So if you take the example for a mixture, so in the mixture you have seen that it contains groundnut and all other ingredients are present. So it have two or more pure substance, so which may be present in any ratio. So it is having a variable composition. So the components retain their characteristic properties. So if you are mixing three components together, so component A, B, and C, so all the three are mixed together, so you are getting a mixture. So here, in the mixture, the components retain their characteristic properties. So the properties of the individual component, it is retained. So the properties of the individual components are retained. So that is the case for mixture. The composition is not uniform throughout. So now the mixture can be separated into pure substance by physical methods. So mixtures of different compositions may have widely different properties. Suppose you have take one mixture, one. Next one is another mixture two. So mixture of different composition. So here the A, B and C. So it is present in 50%. So here it is 30%, here 20%. So in the mixture two, A, B, C. So they are differing in different compositions. So now it is present in 25%. So this is 50% and 25%. So mixtures of different compositions may have widely different properties. So now the properties of mixture 2 is different from the properties of mixture 1 because the composition is not same. So it is different. So what are the example for mixture? Air. So can you tell what is the various gases present in air? Air, what are the components present in air? Nitrogen, oxygen, carbon dioxide. So we have a mixture of all the gases, nitrogen, oxygen, hydrogen, so carbon dioxide. So can you tell whether it is a homogeneous mixture or heterogeneous mixture? So it is a homogeneous mixture. Gasoline, what is gasoline? What is gasoline? So gasoline, it is nothing but it is petrol. So gasoline, it is petrol. It is a mixture of hydrocarbons. So it contains from C5 to C9. So the carbon atom, it ranges from C5 to C9. C5H12, pentane. So pentane, hexane, heptane, octane, nonane, இது எல்லாமே mix ஆயிருக்கதான் வந்து gasoline. So we cannot differentiate. So it is a homogeneous mixture. So next classification is pure substance. So in the case of pure substance, the composition is fixed. The composition will not change. So a pure substance cannot be separated by simple physical method. So properties do not vary. So since it is a pure substance, the properties will not change. So example, diamond. So it is a pure substance. What is the element present in diamond? So graphite. So it is also a carbon. So glucose. So glucose, what is the formula for glucose? C6H12O6. So it contains fixed composition of carbon, hydrogen, and oxygen in glucose. So pure substance are further classified into two types, elements and compounds. So an element means it contains only one type of atom. So for example, if you take carbon, so carbon, it is a element, pure substance. It contains only carbon atoms. So if you take aluminium, so for aluminium, it contains only aluminium atoms. So an element consists of only one type of atom. So it cannot be decomposed further into simpler substances. Already it is contains one atom. So one type of atoms. So it cannot be further divided into simpler substance. So example is sodium, hydrogen atom, copper atom, oxygen atom, silver atom. So these are pure substance. So compound, how a compound is formed? By combining two or more elements. So when two or more elements in definite proportion by mass, when they combine with each other, it forms compound. So the constituent elements do not retain their properties. Only in the mixture, the components retain their properties. So for example, the hydrogen and oxygen, so they combine with each other, they form water. So the properties of water, it is different from the properties of hydrogen and oxygen. So the constituent elements, they do not retain their properties in the compound. So example, water. So water is formed by combining two hydrogen atom and an oxygen atom. So carbon dioxide, it is a combination of carbon and oxygen. Ammonia, so nitrogen and hydrogen gas. So mixtures are classified into two types, homogeneous mixtures and heterogeneous mixture. So homogeneous mixture means the composition is same throughout. So components are indistinguishable. So even though we mix two components together, so we cannot differentiate what is that component 1, what is that component 2. So they are completely mixed with each other. So it is a homogeneous mixture. So for example, sugar solution. So we are mixing so sugar in water. So after mixing, so water and sugar completely mixed with each other. So we cannot differentiate. So gaseous mixture, air, it is a homogeneous mixture. So we cannot differentiate which is nitrogen gas, which is oxygen gas. So we cannot differentiate. So the second type is heterogeneous mixture. So you can see this diagram. So it is a heterogeneous mixture. So here the component 1. So it is one first component. This is another component. So now clearly we can be able to make a distinction between these two. So now there is a separation between these two phases. So this is one phase. This is another phase. So they are distinguishable. So they do not have same composition throughout. So the components are distinguishable. So can you tell an example for a heterogeneous mixture? Sand and water. So sand and water and oil and water. So all these are examples for heterogeneous mixture. So water plus kerosene. So the properties of matter can be classified into two types, physical properties and chemical properties. What is physical property? So we can measure this property or observe this property without changing the identity or composition of the substance. So the properties which can be measured or observed without changing the composition or the identity of the substance, it is called as physical property. So example is color, odor, melting point, density. So all these can be measured without changing the composition of the original substance. So next is the chemical property. So the property which can be measured by a chemical change, it is called chemical property. So examples are basicity, acidity, combustibility. So all these are examples for chemical properties. So now let us study about the measurement of physical properties. So whenever you do some scientific investigations, so we need quantitative measurement of property. So the exact value of each property. Suppose if you are measuring conductance, so you should know what is the value of conductance. So or if you are measuring resistance, so what is the value for resistance. So quantitative measurement of property is required for any scientific investigation. So any quantitative measurement is represented by a number and it should have the unit. So whatever the value we are measuring, so it has a particular value. That value that is followed by unit. So here now we are going to study about this quantity of measurement. So that is magnitude of physical quantity is nothing but the numerical value multiplied by the unit. So whatever the value we are getting multiplied by the unit, that will give you the magnitude of the physical quantity. So unit. So what is a unit? It is some fixed standard. So unit is defined as a fixed standard against which the comparison of physical quantity can be done during the measurement. So any standard should be there. It is a fixed standard. So now we are going to compare whatever the reading we are taking, we are going to compare with that standard. So comparison of physical quantity can be done during the measurement. So the units are classified into basic units and derived units. So in the case of basic units, we have CGS system, FPS system, MKS system and SI system. So what is CGS system? What does C represent? So this is for centimeter, for measuring length and weight, mass. So gram. So mass is measured in gram and time it is measured in seconds. So this is called the CGS system. So FPS system, what does F represent? So the length is measured in foot. So P means pound. So the mass it is measured in pound. S is, so time it is measured in second. So MK system, so meter, kilogram and second. So the next is the SI system. So in SI system, so it is called as International System of Units. SI system, it is the International System of Units. So the International System of Units, SI system, measured in meter, mass it is in kilogram, time on the second. In addition to that, it also contains electric current in amperes, so temperature in Kelvin. So the amount of substance, it is represented by mole, and luminous intensity by candela. So these are the 7 basic units, quantities and their units in SI system. So next we are going to study about multiples. So prefixes. So you should know what is the value for the prefix. So we are using in calculations, you will be using many zeros. So it is difficult to do the calculation. So we have to use the prefix. So 10 power minus 24 means yocto. So the symbol is small y. So 10 power minus 21, zepto. So Z. Minus 18, 10 power minus 18 is atto. So small a. So 10 power minus 15 means femto. Small f. So 10 power minus 12 is pico. So 1 picometer. That means 10 power minus 12 meter. So 10 power minus 9. Can you tell what is 10 power minus 9? Nano. Small n. So 10 power minus 6 is micro. So 10 power minus 3 is milli. Small m. So minus 2 is centi. So minus 1 deci. So 10 means deca. So dA. So symbol is dA. And 10 power 2 is hecto. So H. So 3 is kilo. K. 6 is, what is 10 power 6? Mega, capital M. So from 10 power 6, we have to use capital letters, capital M. 10 power 9 is giga, G. 12, tera, T. So 15, peta. 18, exa. So 21, zeta. So 24 is iota. So these are the various prefixes used. So now let us study about some of the physical quantities: mass, weight, volume, density, and temperature. So which is constant? Mass is constant or weight is constant? Which varies from one place to another place? So weight varies from one place to another place. Why weight varies? So it depends on the gravitational force, so which is acting on a particular object. So mass is constant. So it does not vary from one place to another place. So mass of a substance is the amount of matter present in it. So weight is the force exerted by gravity on an object. So weight is a force exerted by the gravitational force exerted by gravity on an object. So the mass of a substance is constant, whereas weight, it varies from one place to another due to change in gravity. So if you study the weight of a person on earth and the weight of the person on moon. So what is the weight of the, suppose if a person weighs 42 kg on earth, so what will be his weight on moon? So the gravitational force on moon is 1/6 the gravitational force on the earth. So the gravitational force on the moon, it is 1/6 times the gravitational force on the earth. So the weight of a person on moon will be 1/6 the weight of a person in earth. So 1/6 into 42. So the weight of a person in moon is 7 kg. So weight varies from one place to another, whereas mass remains constant. So the SI unit of mass is kilograms. 1 kilogram is 1000 grams. So the next quantity is volume. So volume has the unit of length cube. So SI system volume has a meter cube. So we can also use smaller volumes to represent volume, centimeter cube or decimeter cube. So a common unit, liter. So we can also use liter, so which is not an SI unit. So it is used for the measurement of liquids. So what is the relation between liter, decimeter cube and centimeter cube? So 1 liter means 1 decimeter cube. So 1 liter is nothing but it is 1000 ml. So that is 1000 centimeter cube. So 1000 cc or centimeter cube. So 1 liter is 1 decimeter cube or 1000 centimeter cube, or it is 1000 ml. So density is mass by volume. So density is its amount of mass per unit volume. So the SI unit is kg per meter cube. So mass is in kilogram and volume is in meter cube. So it is kg per meter cube. So density we can also express in gram per centimeter cube. So the next is the temperature. So can you tell what are the 3 common scale to measure temperature? Celsius, Fahrenheit and Kelvin. So what is the relation between degree Celsius and Fahrenheit? If suppose in degrees, if it is given, then we can change into degree Fahrenheit. So the formula is degree Fahrenheit is equal to 9/5 degree centigrade plus 32. So degree Fahrenheit is equal to 9/5 degree centigrade. So plus 32. So this is the conversion. So suppose in degrees it is given, how will you convert in Kelvin? So if you want to convert into Kelvin, so that is from Celsius to Fahrenheit or Fahrenheit to Celsius. So if degree Celsius is given, then you have to convert to Kelvin. So for that you have to add 273.15. So if you want to convert from degree Celsius to Kelvin, so it is, so we have to add 273.15. So the next term is scientific notation. So scientific notations are used when you are dealing with extremely large numbers or extremely small numbers. So how to represent a term in scientific notation? So capital N into 10 power small n. So capital N represents the digit term and small n represents the exponent term. So the capital N, the digit, it varies from 1.000 to 9.999. So 1.000 and 9.999. So small n is an exponent. So the value can be either positive or negative. So the speed of light is, this is a value, huge value. So we can represent in scientific notation by, so you have count how many zeros are there, 5, 7, 8 zeros are there. So we can write this as 3 into 10 power 8. So meter per second. So I'll give you some number just to express in scientific notation. So 232.508. So 232.508. So how will you represent in scientific notation? So whenever you move the digit to the left hand side, so when it is moved to the left hand side, so exponent will be positive. So exponent will be positive.